Hi guys, Miss Brummel here. This is the second part of 1.4 where I'm going to talk about the squeeze theorem. So the squeeze theorem states that if we have three functions where they're kind of in a line incrementally, so f is smaller than g and g is smaller than h or equal to, okay? So there's kind of three functions. If we find the limit of these outer two functions to be the same, then that middle function must also have that same limit, okay? So we're going to apply this to x times sine of 1 over x, okay? And we're finding the limit as x approaches 0. Okay, so something to remember, you guys, is that sine, no matter what argument is, always has to live between -1 and 1. This is true for this as well. Okay, this has to be true. Sine of whatever has to be between -1 and 1. Now, if you guys recall, this is a compound inequality. I could also rewrite that using absolute value and say that the absolute value of sine of 1 over x is less than or equal to 1. So these are equivalent, okay? Now, okay, so this is an inequality. If I were to multiply both sides by the absolute value of x, so why I'm doing that, I can multiply absolute values together, like combine them inside, so that'll equal what I want it to equal here. And also, that's going to make sure I keep this positive so that when I multiply over here by absolute value of x, it's not going to change the direction of my inequality. So in doing that, we get the absolute value of x sine 1 over x is less than or equal to the absolute value of x. Okay, so now this, I'm going to turn back into an and compound inequality. So it's going to turn into negative absolute value of x less than or equal to x sine 1 over x less than or equal to the positive absolute value of x. Okay, so here's my three functions, like up above, f, g, and h. G is the function I actually want to find the limit for, but these ones are easier for me to find. So I'm going to find the limit of f of x and h of x, and if they're the same, that will give me my g of x. Okay, so the limit as x approaches 0 of negative absolute value of x, so if I just substitute in 0, I'm going to get 0. We're going to do the same thing with this one. Limit as x approaches 0 of absolute value of x, same thing, substitute 0, we get 0. So because both of these outer functions, their limit is 0, the middle function must also have a limit of 0. So we're going to say, so by the squeeze theorem, the limit as x approaches 0 of x sine of 1 over x equals 0. All right, and that's it for 142.